On this video, I will be discussing about special right triangles, and specifically this will be about the 45-45-90 triangle. And we have here an illustration from the Call of Duty mobile wherein we took a photo of the map of the Battle Royale, and I have drawn an illustration to show a 45-45-90 triangle right here. So from a location and the diner going to the overgrown has same length from the overgrown going to the nuclear plant, meaning this side AB is congruent to side CB. This is actually an isosceles triangle wherein two legs are congruent, meaning they have the same measurement. If two sides are equal, it will follow that the angles are also congruent, and that will be vice versa. If the angles are congruent, the side opposite them are also congruent. So just like this, angle C and angle A are both 45-degree angle, and it will follow that CB is congruent to AB. That is why we have used A to show that this side AB is congruent to side CB. And the opposite of 90 degrees, which is angle B, is A square root of 2, which is the hypotenuse. So these are the proportion that we should remember when we consider a 45-45-90 triangle. So this is a special right triangle wherein it will follow that the proportion of its side lengths are on the opposite of 45 degrees. Those are A, since we have two 45-degree angle, and then on the opposite of 90 degrees, that is A square root of 2. Now, to give an example of that, let's say for example, A is equal to 1, it will follow that the other leg will be also equal to 1. And this will be 1 square root of 2. The hypotenuse will be 1 times square root of 2, or simply square root of 2. So those are the side lengths of this triangle ABC, which is a 45-45-90 triangle. 1, 1, and then on the hypotenuse, that is square root of 2. And as we know, on the Pythagorean theorem, the sum of the squares of the two legs is equal to the square of the hypotenuse. In this case, our two legs are represented by A, so we have A squared plus A squared. And our hypotenuse is represented by, of course, let's say that is C. If we are going to retain that, we'll be able to identify that your hypotenuse really measures A squared of 2. So let us show that. Since these are like terms which has same base and an exponent which is the power of 2, we can actually combine that, so that is 2A squared. And as we can possibly observe, we can actually cancel out those powers of the following by using a square root. So square root of C squared is C, because that will cancel out, and then we'll retain C at the right side. And then this will be square root of 2 is simply square root of 2. Square root of 2 cannot be simplified, so we'll retain that inside the radical symbol. And then square root of A squared is simply A. So as you can see, the hypotenuse really measures A square root of 2. Let's say for example, since I have used 1 unit for the legs of this triangle by application of the Pythagorean theorem, if that is 1 squared plus 1 squared, we'll end up with Let's say we're solving for the hypotenuse c squared. So c is unknown, which is the hypotenuse. 1 squared is 1, and then that is 1 plus 1. We just copy c squared. And then to isolate c squared, we need to find the square root of both sides. Of course, 1 plus 1 is 2, so that is the square root of 2. This will cancel out. So it will follow that c is equal to square root of 2. As we have written in writing the proportion, the hypotenuse is square root of 2, given that the sides are both 1 unit.